Hello my dear students, welcome back to my class. In the series of learning data structures through C, in the previous videos we have discussed the algorithm of Enqueue and Dequeue. Well, in today's video we will discuss about the complete code of both Enqueue and Dequeue using arrays. So we have seen the algorithm of how to implement Enqueue and Dequeue using arrays. So we have seen the algorithm in the previous videos. In today's video, we will discuss the complete program on how to perform these operations, that is enqueue operations and dequeue operations with arrays. So those are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video, and if you like the video, please click on the like button and share the video to all your friends. So let us understand this Enqueue and Dequeue program. So before we get into the complete program, we have to know the modules that what we are using in the program, because it's a very lengthy program and a very complex program also. And implementation with arrays or implementation with linked list with Enqueue and Dequeue operation is quite complex, and it is a very lengthy coding that what we should learn. So let us understand the modules first, and we will see the implementation of each and every module one by one. The first module is Enqueue, second module or the second function is Dequeue, and finally display. So we have three functions: Enqueue for insertion, Dequeue for deletion, and display for displaying the values that what we have in the queue. So let us understand the arguments and return type. The return type of this enqueue function, the name of the function is enqueue. The return type is void, and it is taking three arguments. One is of integer, which is the element that what I need to push. Then we have integer pointer, means we are sending the address of the pointer. So we are using these as the pointers. We have two pointers, two ends wherein which the insertion and deletion takes place, right? So the insertion takes place at one end and deletion takes place at other end. So we all know this. We have seen this in the introduction of queues. Any doubt with respect to these modules, you can just refer to the algorithm that what I have dealt in the previous videos. You can check out the playlist. So integer asterisk means I am sending the address of a pointer to perform insertion. So we perform the insertion operation with the rare pointer. So we need to send the address of the rare variable, and I need to receive that with a pointer variable. So it is asterisk there. So I am sending the address of the rare variable. So the address will be received with a pointer. So I am using asterisk there in the declaration. So all these are function declaration that what we write before we start with the main function. Then we have the integer array. So integer array is used, and we use the alias name in the definition. So all these are function prototype. They are called as function prototype. Prototype means declaration. Prototype, or what we can call it as declaration. Okay. Now in the same way we have dequeue. So this array I think you can only understand when we get into the implementation. So we are trying to understand this enqueue and dequeue operation. We are implementing enqueue and dequeue with arrays, using arrays. So we should provide the array, and there we use the alias name. So alias name will be the alternate name referring to the same location, and I can have the same values there. Same way we have dequeue. Again dequeue having three arguments, but just observe here we are sending two pointer, because I am sending the address of front pointer as well as the address of rear pointer. So when I am sending the address of the two variables, front and rear, because it is dequeue operation, we should know the values of both front and rear. Okay, so we are sending the address of F, address of R, and the array. So when I am sending the address of the variable F, that is front variable, and rear variable, I need to receive that with a pointer variable, and hence it is asterisk there. So I am receiving that to pointers. In the definition you will get to know. And we have display, again the three arguments. We have the front variable address received with pointer, rear variable address received with pointer, and the array. This is with the prototype or declaration. So let us get into the program now. So here we go with the half portion of the program. Before this main function, we need to write all those function declarations. Prototype has to be mentioned first. Then start with the main function. Then write the program. So we are trying to implement this enqueue and dequeue with switch operation. With switch we are going to take the choice of the user and perform enqueue, dequeue and display. So we have the variable ch to take the choice of the user and the element that what I need to insert into the queue. F is for front pointer or front variable and R is for rear. So front and rear, and the array name is Q and the size that what I have given is 5. So the array name is Q. So we have the variable front, F, rear, R. Okay. Now we have two initialization. So what we are doing, we are trying to initialize the front and rear to some initial values. Say 0 and R is -1. Front, we say it is to the first position, 0, front, 0. And R is -1. Then we start with an infinite loop. When we enter into the infinite loop, we get this message first. So in the output screen, what we will get? We will get all these messages like the options. It will be displayed like a menu card. 1, 2, 3 and 4. 1 means enqueue, 2 means dequeue, 3 means display and 4 means exit. So these options will be displayed to the user. Then I get a message asking for the choice. Enter your choice. So when I say enter your choice, after reading this message, I need to select one of these options. I'll just say 1. So that will be stored in the variable ch. So if I just take 1, so ch will be having that 1. Then I will pass this value to switch. So let me write the code of the switch now. So here we go with the function definition and the switch block. So we are inside the for loop. We have seen the message. The message will be displayed. As soon as the message we read, we take the choice. Let us assume we have taken enqueue operation. We have taken the choice as 1. So the ch value, the variable ch is having the choice 1. So I have given the choice as 1. So switch off 1. So we are inside the infinite for loop. So we are inside the loop. We get that message. As soon as we read that message, we enter our choice. The choice value is 1. So then we say switch off choice. Switch off choice. Continue with the same program. Switch off choice. So case 1, I'll get a message. Enter the item. So that message I'll get, enter the, after all those messages, that is 1, 2, 3, 4, enter your choice, I'll give 1. Then I'll get the message, enter the item. So I'm going to enter the item as 10. That will be accepted with the variable item. So item will be having 10. So here, inside the switch, we get this message and we accept the item. So after we accept the item, what we need to do? We need to call the enqueue function. So here comes the function call. So this is what the function call. So we have the function call. So this function call, we are calling enqueue function by passing 3 arguments. As we have seen the arguments in the function declaration itself, it is having 3 arguments. One is the integer variable. The second one is the pointer variable because we need to send address. The third one is the array. So we only have to pass the array name. We all know how to pass the array to a function. The array name acts as implicit pointer. Look at here. So when I say q, we have declared that q there itself. Q will be acting as implicit pointer, that is the name. The array name itself is q, right? The array name is q it will be acting as implicit pointer because it will be pointing to the base address. What is base address? Address of the first element. Address of the first element, so it is 100, 101 will be the first element address. So we will take the first portion of the address. We will take the first byte of the address. So it is base address means 100 will be held in the array name. So this array name will be acting as implicit pointer pointing to the base address. Base address means address of the first element. Say first element will be in queue of 0. Right. Then it goes on the remaining addresses. So we only pass the base address. So here let me come to this portion. I am taking the value to this function enqueue. So item means what I have given? I have given it as 10. So I am passing 10. Address of R. So R means I have declared the variable R and I have initialized that to -1. What is the address of R? Address of R is 400. What is Q? Nothing but array name. Array name will give you the base address. What is base address? It is 100. So I am calling this enqueue function by passing all these values. Let me come to this enqueue function. So this is function call and this is function definition. This is function definition part. So this is function definition header. So where the function definition header, we should write all those values now. What is item? I am receiving this with the formal variable ITM. Right. I am receiving 10. So this is receiving 10. Pointer variable R. I am writing here. This is pointer variable R which is receiving the address of R. This is actual argument. This is formal argument. Actual argument R is nothing but address of R. What is address of R? It is 400. This is in the main function. This is the sub function. Don't get confused. This is the, I am ending the main function here. This is the main function. This is the sub function. So here I am passing the address of R. What is address of R? It is 400. So pointer variable R. This is the formal argument. New variable. Pointer variable R. Getting this address means 400 means it is pointing to this location. This is pointing to this location. Then Q. Q means it is the alias name, new array name means it is also pointing to the same location 100. So this is array Q pointing to the base address. So I have item ITM, then I have the pointer variable R which is pointing to the address of the rare variable. Both are same name but this is normal variable, this is pointer variable. This address, normal variable address is passed. This normal variable address is received into a pointer variable R. If you get confused, you can just write that as rare itself. Okay. So it is R. R is receiving that address means what is the address of R? It is 400. Means to say this pointer variable R is pointing to the location 400. That's the meaning. Then you have 100 means it is the address given to this alias name, array name Q. So Q is also pointing to the same location means it is the array pointing to the base address. Right. Let us get inside now. So we need to start the enqueue operation. I said pointer R equal to 4. First I need to check whether the queue is empty or not. Pointer R, value at the location R, it is -1. Let me write the iterations here. So, value at R, so what is the value at R? Value at the location R, R is the pointer variable, R is the pointer variable, R is the pointer variable pointing to the location 400. See, you can just put the arrow mark like this. It is pointing to the location 400. The same way here also. Right. So, value at the location 400 is -1. Let me check now. Is -1 equals to 4. 4 means that is the queue size. At the declaration itself, I have given Q of 5. So if the pointer variable rare equals to Q size minus 1, then I should get a message Q is full or overflow. But the condition is not satisfied. The condition is false. Come to the else part. I say value at the location R equal to value at the location R plus 1. R is pointing to 400. Value at the location 400 is minus 1 plus 1 means 0. So value at the location R is now 0. Then I say Q of asterisk R. R is pointing to 400. Value at the location 400. That is Q of 0 equal to the item that what I have received. The array name Q of 0. Q of 0 equal to it is 10. Then get back to this block. Enqueue, then again say break. When I say break, I need to come out of the switch block, but I will be inside the for block. I will be inside the for block. Once again, I will get that message, all those messages. Enter the choice 1, 2, 3, 4. Once again, if I give 1, enqueue, once again, then I say choice 1. Choice 1, again enter the item. So if I just enter the item as 20, then again pass 20, 400 and 100. Again the loop goes back. Here next item is 20. Then here what I do? I check is value at the location R is 0. 0 equals to 4. No. Condition not satisfied. I'll come to else block. In the else block I say it is 0 plus 1. 0 plus 1 it is 1. 0 plus 1 it is 1. The new item 20 will be stored. So what I will do now, when the value 20 is stored to Q of 1, here this value at the location R, 0 plus 1 has become 1. Look at here. 0 equals to 4, condition not satisfied, value at the location 0 plus 1 it is 1, so it is 1. Then Q of 1 equal to the new value 20. Again get back, you come to this point, there will be a break. When you come out of the switch block, you will be inside the for loop. When you will be inside the for loop, once again the same message 1, 2, 3, 4. Again when you enter the choice 1, then switch off 1, again enqueue. So then I will say the next item that what I am storing is 30. So here comes 30, same addresses, everything remains the same. But here what happens? Value at the location R is 1. 1 equal to 4? No. Condition not satisfied. Then I say value at the location R it is 1. 1 plus 1 it is 2. 1 plus 1 it is 2. So here Q of value at the location R it is 2. So 1 plus 1 2, value at the location R becomes 2. Q of 2 it is 30. The next item 30 I am going to store. So here what happens? 30 will be stored. So Q of 0, 1, Q of 2, then Q of 3, then Q of 4. So again loop back, again if I take the choice, again the new item, say the next item I will take 40, then go back, then check the next item 40 will be stored, the same addresses, value at the location it is 2. 2 equal to 4, condition not satisfied, I say 2 plus 1 it is 3. 2 plus 1 it is 3. So value at the location R changed to 3. So here again I will say Q of 3. Q of 3, next item, so what I have taken it is 40. So it is 40. Go back, again you get the choice, then again case 1, then the new item I will take it as 50. I am passing that to the function 50, the same addresses everything. Then here it is 3, again 2 plus 1 it is 3, check, is 3 equal to 4. Condition not satisfied, come to this point, it is 3 plus 1 which is 4. So here Q of 4 equal to the next item say 50. Q of 4 say 50. So again I have to loop back. Here it is 3 plus 1, it has been changed to 4. Loop back. Once again I will give the choice, I will take the item also. But here when I come to this position, it is 4. Is 4 equal to 4? Yes. Condition satisfied, then I'll get a message queue is full. Then again get back, you can take the next choice DQ. So this is with the Enqueue algorithm. So we have inserted the elements, we have got this message. You need to trace out these values by yourself, then you can understand this Enqueue operation. So this is what with Enqueue. In the next video, we will see the DQ function. So that's all for today's video. So in the next video, till then, take care. Bye-bye.